Water. Water is the basis of all life on earth. Without water, even the smallest of organisms cannot live. Water is unusual and incredible. Scientists even research to find water on other planets. Water has surprising properties that we are going to learn today. Welcome to Merrymoppetsguild, fun and exciting STEAM learning lab. Today we are going to do experiment called wet coins. We need coin, pipette, water and a cloth. How many drops can this coin hold? Let's fill this pipette or the dropper with water and drop water on the coin. Slowly and steadily. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. It's full. Will it hold more? Yes. Oh, it's holding 3, 4 more drops. Oh my God. It's holding even more. Are you keeping the drops in count? Looks the coin can hold lots of water. Looks like it, yeah. Looks like the coin can hold only this much water. Why did this coin, the small coin, hold lots and lots of water? That's because water is sticky. What? Water is sticky? Yes, it is. Let's see why water is sticky. The answer is intermolecular forces. Intermolecular forces are forces that hold molecules together. Water is made up of one oxygen molecule and 2 hydrogen molecules. When water molecules get attracted between one another, that is called cohesion. Water has one oxygen molecule and 2 hydrogen molecules. Let's draw it in this way. One oxygen and 2 hydrogen molecules. When water molecules get attracted between one another, it is called cohesion. They love to stick together. One molecule says, "I love you" to the other molecule. That's cohesion or cohesive force. So all the molecules, when they get attracted to each other, they say, "I love you" to the other molecules. All the molecules feel these forces equally, but when they interact with any other surface, it differs. They say, I love you too. This is called adhesion or adhesive force. Let's talk why the water molecules when dropped on water gets this dome shape. Any water molecules, when you take it out of the pipette also, when you drop it, you can see the spherical shape. Let's talk about that. When water molecules get attracted between one another, it is called cohesion. Most of the molecules feel these forces equally, but not for molecules that are at the surface of the liquid. These molecules only interact with half of many molecules as the others because they are at the edge of the substance with no more molecules to one side. So molecules at the edge can make as many interactions. This is why liquids like water contract in order to minimize surface area. That's why the drop of water is spherical and forming a dome shape. When this droplet becomes larger, then gravity and air resistance comes into play. See, the dome is getting larger. Once the dome is getting larger, the gravitational force and air resistance come into play. And that's why they don't remain spherical longer. But if you see, in this tiny droplet, this effect is still there. It is still spherical in shape. Let's talk about adhesion. The interactions between the molecules of a liquid and some solid surface are called adhesive forces. Here, the water molecules are in contact with this coin. The water molecules say, I love you to the coin. I love you to the surface of the coin. These describe the ability of a liquid to adhere to that surface. Now, we are dropping water onto this coin. It maintains the spherical shape. This is because the cohesive forces between the water molecules inside the droplet are stronger than the adhesive forces between the water and this coin. Now children, let's talk about surface tension. Surface tension is defined as the energy required to increase the surface area of a liquid. This depends on the strength of cohesive forces in the liquid. How much they love each other. If they love more, then the surface tension increases. So stronger cohesive forces, stronger surface tension. Different liquids have different surface tension, and water has very high surface tension. The hydrogen bonds are very strong. They are very good friends. That's why when we drop water, we can fill the coin with as many drops as we can. But if you try the same experiment with other liquids, see how many drops can you fill in the same coin and come up with the results. Aren't the properties of water unusual and incredible? Let's learn properties of water with Merrymoppetsguild. Until then, bye children.